Hello everyone. Today, as part of memory management chapter, we are going to look at garbage collection and variable scope. What is garbage collection? It's basically a program's executable which includes automatic behavior that at various intervals finds all unreachable, which means unused, allocated memories or memory locations and try to free those unused memory locations in order to enable memory reuse. In the image towards the right hand side you can see an object inside a heap, and if there is no reference left to it, the object is dumped from the heap, which means it's being freed up to be able to be reused. Automatic garbage collection, it's a process of looking at heap memory and identifying which objects are in use and which are not. Thereby, you're allowing the garbage collector to delete those unused objects. An in use object or a referenced object means that some part of your program still maintains a pointer to that object. On the right hand side, you can see references to the objects within the heap. Likewise, an unused object or unreferenced object is no longer referenced by any part of your program. So, the memory used by an unreferenced object can be reclaimed by the garbage collector. In Java, process of deallocating memory is handled automatically by the garbage collector. What it basically does is mark the objects and sweep them out of the heap and compact those objects together. Let's see the basic process in garbage collection. As I said, the step one is marking. This is where the garbage collector identifies which pieces of memory are in use and which are not. On the right hand side, you can see the first square which I am highlighting now is before marking. This is the memory space before marking, and this one's after marking. So what this basically does is the referenced objects here in the image are shown in blue and the unreferenced objects are shown in the gold. So in order to do this, all objects are scanned in the marking phase to be able to determine which are in use and which are unreferenced. So once the objects are marked, the memory space is going to look like this. Step 2 is deletion. Normal deletion removes unreferenced objects, leaving referenced objects and pointers to free space. So the memory allocator holds references to blocks of freed up space where new objects can be allocated. So once the objects in the gold in the previous slide are removed, the memory allocator also holds these references as a list so that these objects can be reused. So deletion with compacting. So once the unused, unreferenced objects are deleted, so to further improve performance, you can also compact the remaining referenced objects, or the objects which are alive can be grouped together. So by moving reference object together makes it easier for new memory allocation, faster and easier. So this is what it does, because you are no longer going to make a list of nodes, because this memory space is contiguous and you can directly allocate them whenever a new object is being created. So as it says, memory allocator holds the reference to the beginning of the free space, not all the references. Only beginning of the free space is being tracked up, and a quicker allocation is possible. Garbage collection concepts in Java. Unreachable objects. It's an object. An object is unreachable if it doesn't contain any reference to it. So an object is eligible for garbage collection if it's unreachable or unused. So in the image on the right hand side, let us correlate the code and the image. In the code, when we create a new integer, the I is the integer and it is referencing an object which is allocated from the heap space. So once you make the object null, the integer object is no longer reachable. So the reference is lost and this object is ready to be freed up from the heap area so that it can be reused. So these are some ways to make an object eligible for garbage collection. So it is always highly recommended to make an object unreachable once you think that it's no longer used or you don't need it. It is always good to make that object available for garbage collection. So these are some ways that the garbage collector picks them, or these are four things or four kinds of variables that the garbage collector picks up. So nullifying the reference variable will make the garbage collection easier. So all the null objects are collected by the garbage collector. Also, you can use the objects which you no longer want to different objects, or you can reassign the reference variable. All the objects created inside the method call are always freed up once the method ends. All the objects part of the unreferenced block of the heap are always cleared by the garbage collector.